In this video, we're going to be talking about the domain of radical functions with various nth roots. So if the root is even, so if n, that index is even, then that value underneath the radical has to be greater than or equal to 0. Okay, we can't take the square root, the fourth root, the sixth root, any even root of a negative number. So everything under that radical has to end up being greater than or equal to 0. If it's an odd root, so third power, fifth power, seventh power, the domain is everything. There's no restrictions. I can put any values I want in for x and it's okay, because with odd roots, when I have an odd number of negatives, I can get a negative value underneath. I can't get a negative value underneath with even roots. Alright, let's look at some examples. The first one here has f of x equals 2 plus 3 times the square root of x plus 4. That 2 plus 3 times the radical do not change the domain. It's all about what's underneath the radical and the index. So this is a square root. Square roots, we cannot take the square root of a negative number. So that quantity, x plus 4, has to be greater than or equal to 0. We've done this previously. So in this case, x has to be greater than or equal to negative 4. Our question asks us to write it as an inequality. So there's our inequality, and in interval notation. So if it helps you, you can make a number line. And I want all the values greater than or equal to. So equal to, I'm going to use a bracket. Greater than, I'm getting bigger, I shade up to the right. So my interval notation is from negative 4 up to infinity. Okay. On part B, this is k of x equals the cube root of x minus 1. So a cube root has an odd index. So this is an odd integer. So that means I have no restrictions on my domain. The values underneath the radical can be positive, they can be negative. I can input anything I want. The domain is just negative infinity to infinity, which generally something like this you don't write with inequality. Alright, go ahead and you try the examples on the right hand side. Let's see how you did. First example, I'm taking the square root. This is an even index, so the expression underneath the radical cannot end up negative. That whole quantity has to end up being a number greater than or equal to 0, because I cannot take the square root of negative numbers. I need to solve this to figure out what the domain is. So I add 3 to both sides. That leaves me with 2x greater than or equal to 3 divided by 2, and x has to be greater than or equal to 3 halves. So greater than or equal to on a number line, again that means I am shading up, and I'm including 3 halves as part of my answer because I can take the square root of 0. I just can't take the square root of a negative number. So there's the inequality. The interval notation would be from 3 halves, or 1.5, or 1.5, up to infinity. Part B. I'm taking h of x equals the 6th root of 5 minus 2x plus 1. This is the 6th root. Again, that is an even number. So the stuff under the radical, doesn't matter what's outside, that doesn't affect our domain, but what's underneath has to end up as a 0 or positive number. So 5 minus 2x has to be greater than or equal to 0 to make it 0, or a positive number. Again, I need to solve this inequality to figure out the domain. What can I put in for x? Start by subtracting 5 from both sides. I have negative 2x greater than or equal to negative 5. Divide both sides by negative 2. What happens with inequalities when we divide by a negative number? It flips the direction of the inequality. This was a greater than, so now it's going to become a less than or equal to. And a negative divided by a negative is a positive. So positive 5/2, or 2.5, or 2.5, however you want to write it. Alright, so that's the inequality. I have to also write it in interval notation. If it helps, you can make a number line. I have 5/2 on here, and I want the values less than or equal to, because I flipped directions. Less than, I shade left. I'm including 5/2, so this would start from negative infinity and go up to 5/2, including 5/2. And there you have it. Thus, if we have an odd index, an odd root, the domain is everything. There's no restrictions. If I have an even root, the expression underneath the radical, and only the piece underneath the radical, needs to be set greater than or equal to 0. Solve that inequality to find the domain.